Good morning, students. I'm Professor Priya Sharma of EC Department, SIRT College, Bhopal. Say Janandam. So this is our lecture series, Digital Circuit System, which we are running these days. So lecture 6 will be on the decoders and the encoders. So first of all, what is a decoder? A decoder is a combinational circuit. It accepts a set of inputs that represents a binary number and activates only that output corresponding to the input number. All the other output remains inactive. A decoder has n inputs and m outputs. So there are possible 2 to power n input combinations. For which of these, only one input combination and only one output will be high and all other outputs will remain low. Some decoders may have one or more enable inputs that are used to control the speed of the decoder. This is the basic block diagram of a decoder having n input lines and m output lines. So starting from the basics of the decoder, first is the 2 to 4 line decoder. Here there will be two inputs, namely A and B, and four outputs, namely D0 to D3. From the truth table, it is clear that each output is 1 for only a specific combination of inputs. Like for 00 only D0 will be 1, and for 01 D1 will be 1, for 10 D2 will be 1, and for 11 D3 will be 1. Similarly, after solving this through K map, we will get that Z, or from the truth table we can see that D0 is A bar B bar, D1 is A bar B, D2 is A B bar, and D3 is AB. We can solve this through a logic diagram, like D0 will be A bar and B bar, D1 will be A bar B, D2 will be A B bar, and D3 will be AB. After 2 to 4 line decoder, we have 3 to 8 line decoder having 3 inputs A, B and C and 8 outputs D0 through D7. From the truth table, again it is clear that only one output will remain active and others will remain inactive for a corresponding combination of inputs. For 000, D0 will be active and can be written as A bar, B bar, C bar and so on. So having 3 inputs A, B, C and 8 outputs 3 to D0 through D7. From the outputs of this, D0, D1 through D7 can be realized using the logic gates, which is being shown in the diagram. Now, I have explained you earlier in the multiplexer that a 8 is to 1 multiplexer or 16 is to 1 multiplexer can be made through a reduced form of multiplexers, like from 4 is to 1 or from 8 is to 1. Similarly, a decoder having high number of inputs and outputs can be made using a smaller decoder, like 3 to 8 decoder can be made from 2 to 4 decoder by using two decoders of 2 to 4. Here one enable input is given, like if you can see in the truth table, from this 0 to this 0, it will be uh, it will be active when the enable input is 0. For these outputs, the enable will be set to high and it will be uh, assuming the same. Like for x and y are the inputs which are given common. So assume that B and C has been replaced by X and Y and A has been replaced from enable. So enable input till it is low or 0, this decoder will be active and D0, D1, D2, D3 will be acting as the outputs. When E is 1, then this decoder 2 will be active and D4 to D7 will be the outputs. Now, if you can see, sometimes it is being asked in the questions or exams. Questions has been asked like implement a full adder using a decoder. So if you remember the truth table of a full adder, it is being having three inputs and two outputs, namely sum and carry. If you write down the minimized form of the sum, it is 1 at 1, 2, 4th and 7th position, which has been written here, and the carry output is 1 at 3, 5, 6 and 7th position. So a 3 is to 8 decoder is being used here for the full adder. So these are the three inputs X, Y and Z and the two outputs sum and carry. So sum is having the outputs from 1, 2, 4 and 7. So we simply connect 1, 2, 4 and 7th output of the decoder using an OR gate and the output will be the sum. Similarly, for the carry output, an OR gate is being used and the outputs like 3, 5, 6 and 7 are being added in the through a OR gate and the carry output is being produced. Similarly, now coming to the encoders, an encoder is also a combinational circuit and it performs the operations which is exactly opposite of that of a decoder. An encoder converts an active input signal into a coded output signal. It has M inputs and N outputs. An encoder has M input lines, only one of which is activated at a given time and produces N bit output code depending on which input is activated. Encoders are used to translate linear or rotary motions into a digital signal. The difference between an encoder and a decoder is that a decoder has a binary code as an input while the encoder has binary code as an output. So this is the basic diagram of an encoder, which is an electronic device and converts an analog signal into a digital signal, having the M inputs and the N outputs. So we will study here three types of encoders. We have listed four. The encoders are priority encoder, decimal to BCD encoder, octal to binary, and hexadecimal to binary encoders. Coming firstly to the priority encoders, as the name indicates, the priority is given to the input lines. If two or more input lines are active at the same time, that is, if it is one at the same time, then the input line with higher priority will be considered, irrespective of the inputs at the lower priorities. So if we consider 4 to 2 line decoder having the 4 inputs and 2 outputs, D0 will have the lowest priority and D3 will have the highest priority. If you look at the truth table, inputs are D3 to D0 and outputs are Y1 and Y0. So if when all the inputs are 0, the output will be at the don't care condition. It could be 0 or it could be 1. When D0 is 1, both the inputs are 0. When D1 is 1, irrespective of the value of the D0, as D1 is at higher priority, the output will be 0 1. When D2 is 1, then irrespective of the values of the D0 and D1, the output will be 1 0. And when D3 is 1, irrespective of the values of D0 through D2, the output will be high at both the outputs. So a priority encoder, there are 4 inputs and 2 outputs, as I have told you earlier. And D3 is having the highest priority and D0 is have the lowest priority. If D3 is equals to 1, then irrespective of other inputs, then the output will be Y1, Y0 will be 1, 1. D3 is at highest priority, so the other inputs are considered as don't care. As it is having the highest priority, the other inputs are considered at the don't care. So solving the K-map for the Y1 and the Y0 outputs, we would get that Y1 is equal to D2 plus D3 and Y0 is equals to D3 plus D2 bar D1. This can be resolved using these logic gates. Y1 will be D2 plus D3 and Y0 will be D3 plus D2 bar D1. Similarly, for decimal to BCD encoder, as we know that the BCD is having total of 10 in decimal digits ranging from 0 to 9, so it will have the 4 outputs A, B, C, D and 9 inputs. This is the 9 inputs ranging from 0 to 9 and 4 outputs. Similarly, from the truth table we can see that A is high at the positions 8 and 9, B is high at the position 4, 5, 6 and 7. C is high at 2, 3, 6, 7 and D is high at 1, 3, 5, 7 and 9. It can be realized using this logic circuit. Octal to binary, as octal number contains only 8 numbers ranging from 0 to 7. So D0 to D7 will be the inputs and having the 3 outputs X, Y and Z. So only one input value has one value at a given time. Each input corresponds to each octal digit and octal generates corresponding binary code. From the truth table, again, we can see that these are the inputs for the corresponding outputs. It is assumed that only one input is high at a given time. If the two outputs are high, then undefined output will produce. For example, if D3 and D6 are high, then output of the encoder will be 111. This output neither equivalent code corresponding to D3 nor to D6. To overcome this problem, priority should be assigned to the each input. From the truth table, it is clear that the output X becomes 1 if any of the digit D4 or D5 or D6 or D7 is 1. So X will be high when either of these will be high. D0 is considered as don't care because it is not shown in the expression. If the inputs are 0, then the output will be 0. Similarly, if D0 is 1, the output will be 0. Again, it can be realized using the expression x will be corresponding to d4, d5, d6, d7, and similarly other outputs can also be realized. So that's all for the decoders and encoders. I hope it is clear now. For any doubts, you can please share and contact with me. The previous links has been described in the description box. For the all the previous lectures, description has been there in the description box. You can go through any of the lectures, previous lectures. In case of any query, you can contact me. Thank you. Sage Anandam, work hard and all the very best. Thank you.